Hello y'all, we are Memphis Communiversity and we are doing another calculus done wrong lesson where we wrong calculus before calculus wrongs us. And today marks a special day because today we are officially starting our shapes of curves units. So basically what we're going to try to do is determine what graphs a function looks like, what are certain properties of graphs for our functions. But the great thing is that we're not going to actually have to graph the function of f because they might be too difficult. What we're going to be doing is we're going to be using calculus, of course. We are going to be using the first derivative and the second derivative to determine properties of the graph of f of x, again, without having to graph it. So today's video is going to be on increasing, decreasing. So what we're going to do is we're going to determine where a function is literally increasing or a function is literally decreasing, going up versus going down, but we're not going to draw the graph of f. What we're going to do is we are going to use the sine chart of f prime to determine what our graph of f looks like. So if you watched our previous video, or if you haven't watched our previous video, please do that because that was on sine charts, and you'll see that the knowledge of how to draw on sine charts is very important for the next video, for this video, and the video afterward, for 3 videos in a row. So let's get started. Again, we are doing increasing, decreasing functions. So f is increasing, f is decreasing. And we are trying to determine it. So just to see what a picture of an increasing, decreasing function looks like, let's take a basic upside down parabola. So we have something like this. So this is going to be my graph of f. Again, we're not going to draw graphs of f, but this is just a little bit of an indication of what even we're trying to do. So if you look at this graph of f, you might have wondered while you were in bed at night, where is this function going up and where is this function going down? So literally where it's going up is where f is increasing, and where it's going down, so about right here, this is where f is decreasing. Imagine if you were just on a roller coaster, are you literally going up or are you in free fall sort of thing? So this is what we're going to try to determine. But again, a lot of times our graphs are too complicated to actually graph, so we're going to do a trick. Not a trick, really, just a calculus little funsies. And what we're going to do is we are going to use the derivative to help us determine where this function is increasing or decreasing. So let me describe the rule. So I'm going to erase this little picture here because after this point, we're not going to draw any f graphs. We're only going to draw f prime sine charts. So the rule is that we're going to use constantly is f is increasing when f prime is positive, and f is decreasing when f prime is negative. So this is going to be our rule that we're going to use quite often, and this makes sense. F is increasing when f prime is positive. F prime, remember, is the slope of the tangent line at a certain point. So if the slope is positive, that means your function is increasing. F is decreasing when f prime is negative. Again, that makes sense. That means your slope is negative, meaning the derivative, so that means you're decreasing. But keep in mind, again, we won't see pictures that go increasing or decreasing. We are only going to be looking at the sine charts of f prime and see where f prime is positive or negative. Again, the sine chart only tells you where things are positive or negative. We don't have any increasing, decreasing charts. So just keep in mind that we are drawing the sine chart, which is sort of the graph, but not exactly the graph of some function called f prime to help us determine what f looks like, even if we never draw f. So the sine chart of f prime, whether it's positive or negative, determines whether another function, f, is increasing or decreasing, even if we never draw. So that's going to be the key here. So our steps basically are, we're going to have a function, we're going to take the derivative, and then we're going to draw the sine chart of the derivative, and then we're going to see where this derivative sine chart is positive or negative. Just like in our sine chart video previously, what we really focused on is we don't really teach how to find sine charts by just plugging in certain points on the interval. What we teach is to just try to know what basic graphs of polynomials looks like when you factor. So that will be the key step every single time, and that's the thing I'm going to try to emphasize as much as possible. Factor every single sine chart, factor every single function before you draw the sine chart. So when we have these derivatives, we are going to factor them as much as possible. But let's get started. Let's go with some examples. So let's erase this. Let's erase this. Let's just see what's going to happen here. So for every single question in this video, the question will be, where is f increasing or decreasing? So let's take our first function x. I'm going to have minus x cubed over 3 plus x to the 7th, not x to the 7th. I don't know what I'm doing here. Let's do 7x squared. That's where I want my 7 to be. let's do minus 8 plus 3, and let's put 8x here. So what we're going to do is we are seeing where this function is increasing or decreasing. So if I were taking a calculus exam, for example, the AP exam, whether that be for fun or whether I was forced, anytime I see the word increasing or decreasing, I think of the rule that I just mentioned that we're going to be using constantly throughout this video. F is increasing when F prime is positive. So immediately I'm like, I need to take a derivative and I need to draw the sign chart of the first derivative. So first step, take the derivative. So the derivative shouldn't be too bad here. Notice that some of my students, when they take this derivative, they might get a little bit confused. Not really confused, but they might do it in an awful way. This is a quotient, so sometimes people want to do the quotient rule. Low D, high minus high D, low, low. But what we recommend is that you only do the quotient rule when there's x's both in the numerator and the denominator. So this guy right here is the same thing as negative 1/3 times x cubed. It's so much easier, just so much easier to use the power rule instead. So let's just see that in action. We take the exponent, drop it to the front, and notice that when we drop this 3 to the front, the 3's will cancel. I can do that step for you. So again, all I did was the power rule, drop it to the front, subtract 1, and the 3's will cancel, and that's why this question's pretty nice. Same thing with this one. I'm not doing the quotient rule. All I'm doing is taking the 2 down, dropping to the front, so it's going to be 7 times 2x, subtract 1, 2 minus 1, of course, is 1, and then we still have divided by 2. Finally, the derivative of minus 8x plus 3 is pretty easy. The derivative of minus 8x is, of course, minus 8, and the derivative of plus 3 is 0. So we have this guy right here. Again, let's try to simplify this as much as possible. These 3's cancel, these 2's cancel. So it looks like we have minus x squared plus 8x minus 8. So we took the derivative, that's the first step. The second step is to draw the sign chart of this derivative. But keep in mind that, again, you really want to factor this thing as much as possible. And what I consider factored as much as possible is x plus or minus something times x plus or minus something times x plus or minus something times x plus or minus something. I do not like, I hate something minus x, which is why I take a negative out if that occurs. So in this case, what I'm going to get is I'm going to factor this as minus, I'm going to take out a negative out of everything because I always want my x squared term to be positive. So it's going to be x squared minus 7x plus 8. Running out of room here, didn't really plan this out, but let's take the derivative here, or let's factor this derivative. So it's going to be, I believe, minus 8x minus, I can't do basic factoring, it looks like it's going to be this, minus x plus 8 times x minus 1. So notice that we do have to do a little bit of algebra steps to get to this point. We need to factor as much as possible, and we have done so. So now that we have factored as much as possible, what we need to do is we need to draw this sign chart. And again, hopefully you watched our sign chart video. If you want, let me just sort of iterate what we talked about in that video. Once you factor it as much as possible, you just count the number of zeros. And in this case, it's 2 zeros, 1, 2, and they each have multiplicity 1, meaning they're to the 1. So this has 2 zeros, and then also it's negative. What does a negative even polynomial looks like? Well, it's an upside down parabola. So in this case, what we're going to do is we're going to draw this upside down parabola. My picture's kind of small here, but hopefully you can tell what's going on. Plot the zeros, of course, so it's negative 8 and 1. And then I just draw a nice little parabola here. So this is my nice little parabola. And then keep in mind, again, this is not a picture of f, the function we actually care about. This is actually the sign chart of f prime. And the rule says, I'm not looking at where f prime is increasing or decreasing. That's actually going to be in our next video potentially. What I'm looking at is, I'm looking at where f prime is negative or positive, because the rule is f is increasing when f prime is positive, and f is decreasing when f prime is negative. So I like to draw actually positive and negatives on this sign chart. And let's answer the question. So where is f increasing? So I tell my students that because these occur so many times on the free response questions of the AP exam or even college calculus exams where you have to work out, I don't even know what I'm saying, where you have to write out all your steps, what you should do is you should write a sentence. So f is increasing when f prime is positive, so we can just put that in parentheses, on the interval negative 8 to 1, because notice that in this sign chart, from negative 8 to 1, this f prime sign chart is positive. So it's on -8 to 1. So you should always have 3 parts to your answer. The original question, where is f increasing? The justification or the rule, which in this video is f is increasing when f prime is positive, and then finally the answer. So let's answer the second question, where is f decreasing? So all we do is look at the negatives. The actual picture doesn't really matter at all because it just helps us draw the sign chart. So again, we're not looking at where this is going up or down, we're just looking at where this is positive or negative. So focus on these signs to do this question. So finally, it's f is decreasing. I'm going to just write the word DEC or the abbreviation DEC because I'm running out. Actually, no, I won't be lazy. So f is decreasing when f prime is negative. And then where this is going to be for x smaller than -8. So we can say x smaller than -8 and also x bigger than 1. So sort of ran out of room here, but hopefully you can tell what's going on. X bigger than 1. And that's it. So next question, hopefully I'll write a little bit smaller, but hopefully you can see that these questions aren't too bad. Again, you take your function, you immediately see the word increasing or decreasing, so you know the rule. F prime is positive, means f is decreasing, so we should immediately try to find f prime, factor that, draw the sign chart, and then just look at the sign chart. So that's what we did. We did not do quotient rule, we just did power rule because there was no x's in the denominator of the questions. So we took that, then we factored it. We drew the sign chart of f prime. This is f prime, so this was a negative parabola crossing through -8 and 1. And then f is increasing when this sign chart, again, we don't care about the actual parabola, we just care about the positive and negativeness. F is increasing when f prime is positive, so from here to here, where's the sign chart literally above the x-axis. And then finally, f is decreasing on the other intervals from negative infinity to -8, from 1 to infinity, or you could write it like this. Hopefully you can tell what it says. X is less than -8, x is greater than 1. So that's all it is. Let's just do a few more examples, and hopefully as we go, you'll see that this process isn't too bad. It's the same thing over and over again. As long as you remember key steps like the rule itself, f is increasing when f prime is positive, and taking derivatives carefully and drawing sign charts carefully after you factor. So let me erase this. Let's try to write the question a little bit smaller this time so we have more space to work. So let's get going. So obviously your functions are going to be a little bit more complicated potentially, but it's still the same rules over and over and over again. So my next one is going to be, where's f increasing or decreasing? So let's actually abbreviate this time. And then let's let my function be e to the 2x times 3x minus 1. So this is going to be my next function right here. And again, what we're trying to do is see where f is increasing or decreasing. I have no idea what this graph looks like, so it's going to be hard to tell where it's going up and where it's going down, but it's going to be okay, friends, because we have the rule. F is increasing when f prime is positive, f is decreasing when f prime is negative. So immediately we want to take a derivative. But keep in mind that when we're taking derivatives, of course, you have to do it correctly. So what we need to do is really focus on the product rule potentially and also the chain rule, whether that be necessary. So if you want, it's keep the first, so e to the 2x. I'm doing the product rule, so keep the first one the same, take the derivative of the second one, times 3, and then time for the second half of the product rule. Because we kept this one the same originally, we need to take the derivative of e to the 2x. The derivative of e to the 2x is e to the 2x. But because there's an n-side function, the exponent itself is an n-side function, we do need to multiply by times 2, so we will do that. This times 2 against the chain rule. My best friend in the world. My life is incredible if you don't know. So finally, at the very end, we're going to keep the second function the same because we took the derivative of the first one. So in this case, it's going to be 3x minus 1. So here's our derivative. And unfortunately, just like we talked about in the previous video, even if we weren't introducing derivatives, you need to factor everything as much as possible again before you draw the sign chart. This does not look factored, so we have to do a little bit of algebra to manipulate things around, to move things around, to factor out stuff so that we can draw the sign chart. So notice the best way to do this is take out everything that is in common with these two things, and in this case it's going to be e to the 2x. Then it looks like we have a 3 left. And then if we distribute this 2, looks like we're going to have 6x minus 2. So we have that. So again, not factored as much as possible, so I'm going to keep going. looks like we're going to have e to the 2x, and then it looks like it's just going to be 6x plus 1. 6x plus 1. So now it looks pretty factored. Now I'm ready to draw the sign chart. So how do we approach the sign chart? Well, just like normal, keep in mind that we're not drawing the graph of f prime, because that would be pretty complicated because of this e to the 2x. What we're doing is just seeing where f prime is positive or negative. So if you watched our previous video, you'll know that e to anything is always positive. E to even negative numbers is always positive. For example, e to the negative 3 is the same thing as 1 over e cubed. And 1 over e cubed is like 1 over 2.7-ish cubed. So that's going to be a positive number. If you take the graph of e to the x, it never crosses the x-axis. So what I say is, when you have these e to the 2x's, after you factor as much as possible, we can basically ignore it because it does not affect the sign chart. It certainly affects the graph of f prime, but it does not affect the sign chart. Unfortunately, the rule is f is increasing when f prime is positive, so all I need is the sign chart. So let's draw the sign chart of this guy. This guy's sign chart is easier than the last one. Whenever you have just this, I like to think of it as just a line, of course, y equals mx plus b. Where does it cross? Well, if you want to do a little bit of algebra, looks like it's going to cross at negative 1/6. The x-intercept, so I'm going to label that point. And then anytime you have a line, you just have to think about, is the slope going to be positive or is the slope going to be negative? Well, in this graph, the slope is going to be positive because it's y equals mx plus b, and is 6, so it's going to be a positive slope line. So just be careful, just because the x-intercept is negative doesn't mean the slope is negative. Then we're going to label this positive or negative, f prime. So again, as my students are learning this for the first time, they get a little bit confused. They think, well, the function looks like it's increasing the entire time because it's literally going up. But that's where f prime is increasing, so keep in mind about that. In this little sign chart, we do not care about this actual line itself. We only care about the sign chart, so the positiveness and the negativeness in these intervals. So that's going to be determining the thing. This sign chart of f prime again tells us about the graph of f, even if we never never actually draw the graph of f. So hopefully that makes sense. So let's go for the answer. Remember, 3 things always. 3 things, just 3 things. First thing, question. Second thing, rule. Third thing, answer. So in this case, we have a little bit more room. So f is increasing. So where is f increasing? Well, f is increasing. I like to immediately write the rule to show them what I got, to show them what I'm working with. So f is increasing when f prime is positive. Where is this positive? On this interval all the way to infinity. So it looks like it's going to be from negative 1/6 to infinity. If you want, you can write this as all the x is greater than negative 1/6. And then where is f decreasing? It's just the reverse, of course. F is decreasing when f prime is negative here. So I'm going to write f prime negative on, and then here's the negative part. So it's going to be negative infinity to this negative 1/6 number. Got too excited, changed my comma to a negative, but hopefully I got there in the end. Let's close this parentheses because it's a point or an interval. So this is all it is. Again, the next few questions are going to be the same method, except that the derivatives might be a little bit more complicated. So let's recap what we did. Let's admire our work. We started with f is increasing. We have this function right here. What we did is we immediately took a derivative, because that's what you do in these questions, f prime. We were careful with our derivative because our derivative required both the product rule, so that's why there's something plus something, and also the chain rule, because as we kept the same derivative for the second derivative, we had to do the chain rule, keep the same. Then the most important step, in my opinion, is to try to factor the derivative as much as possible so that the sign chart is as easy to draw, which is what we did here. We have this f prime, looks like this, and then f is increasing on these intervals. F is decreasing on these intervals because f is increasing on this one because the derivative f prime is positive, and then f is decreasing on this interval, negative infinity to negative 1/6, because f prime is negative there. Keep in mind that, in my opinion, you should just be very specific. I don't like even when my students write f is increasing when the slope is positive, or even the word derivative, or it is positive. Just write f prime, just write f prime positive, f prime negative. So let's keep going. Let's not stop here. Let's just do more and more examples so that we really master this sort of topic. So I'm going to erase this again. Let's do a little bit more complicated. Maybe not more complicated, but around the same level. It is a Saturday morning after all, we can't go too crazy. So let's go here. We got this, let me erase this guy. Let me do the function 2x minus 1 cubed times x plus 3 to the fourth. So again, we're doing increasing, decreasing. First step is take the derivative. Let's take the derivative. Just be careful. Of course, we need the product rule and potentially the chain rule. So let's take this derivative. One thing is to use the derivative rules that we are given us. Accept your gifts. Like, don't make your life hard. It would be super, super awful to multiply all this out. You would not get anywhere and you would take a lot of time. So anytime you have these functions, just start taking derivatives. So in this case, we're going to take the derivative. So I'm going to keep this one the same. 2x minus 1 cubed. Then the derivative of this will be 4 times x plus 3 cubed. So this is only first half of the product rule. Notice I did the power rule here. I took the power, dropped it to the front, subtracted 1. So that was the first half of the product rule. Now for the second half, it's going to be equally exciting. The derivative of this one, still the power rule, 3 times 2x minus 1 squared. But keep in mind that we do need to do the chain rule because the derivative of the inside function here is not just 1 like the previous one where the derivative of x plus 3 is 1. In this case, the derivative of 2x minus 2 is times 2. So we do need to have this times 2. Don't forget this little guy. He's a little bit lonely, but we need to remember him. Finally, we're going to keep the same. So it's x plus 3 to the 4. So this is the step, if you remember the chain rule and the product rule, that my students usually can remember, but what some of them unfortunately do is that they immediately start trying to draw the sign chart. But again, you can only draw the sign chart when it's factored as much as possible, and this is not factored as much as possible basically because of this plus. We need it of the form x plus or minus something to a power, x plus or minus something to a power, x plus or minus something to a power. So that's what we're going to do here. We're going to try to factor and keep factoring and keep factoring. And when you factor this, just like with the e to the 2x case, what you want to do is be familiar and take out everything that is in common. So in this case, notice that there's both of these guys, so this first thing and this second thing, both have 2x minus 1, so I'm going to factor that out. And how many 2x minus 1s do they have in common? Well, this one has 3 and this one has 2. So how much do both of them at least have? That's going to be 2, so it's going to be 2 here. And then how many x plus 3s do they have? Well, this one has 3, this one has 4, so they at least have both 3, so I'm going to factor that out as well. So that's going to be 3 things. If you're feeling bold, you notice that they both have times 2, so we can factor out a 2 as well. We might as well do that, so let's put that in the front. Put the constant in the front of the parade there. And then what we're going to be left with is the hard part, but let's just see what we're left with. So for this first half of the product rule, we took out a 2x minus 1 squared, so it looks like we still have a 2x minus 1. We already factored out all of the x plus 3 cubes, and then we factored out just 2 of the 4. So it looks like we're going to have 2 times 2x minus 1. So again, hopefully you see that the algebra sucks, but what we had to do is we had to do a bunch of algebra steps to factor as much as possible. The calculus actually wasn't that bad. So let's do the same thing over here. Let's take out everything that was in common and let's see what we have left. Sorry, I'm getting too excited. So what we took out is 2x minus 1 squared. We also took out an x plus 3 to the cube, so there should be one more x plus 3. And then finally we took out a 2, so it looks like it's going to be 3 times x plus 3. So it looks like we're getting somewhere. We are factoring as much as possible. We have factored this, we have factored this. So now what we need to do is just simplify this guy and we should be good to go. So let's do that real quick. 2 times 2x minus 1 squared times x plus 3 cubed. I'm going to try to do it all in one line because I want to have a lot of space for my sign chart because I love my pictures to be pretty nice. So I'm going to try to do this. Hopefully you can follow along. So let's try to combine all the x's together. It's going to be 2 times 2x, which is 4x, plus this 3x, that's going to be 7x. So this is going to be 7x. Then we have minus 2 plus 9, because 3 times 3 is 9. So it looks like that's going to be plus 8, I believe. Let's check our work. It's going to be 4x plus 3x minus 2x plus 9. Oh, sorry, I might have done that wrong. So let's do this again. Minus 2 plus 9. I believe that is plus 7. Sorry, I can't do math. I believe that's right. So 4x plus 3x is 7x. That's great. Minus 2 plus 9 is plus 7. Sorry, I can't do math. But notice that this is actually pretty nice. Let's actually just take out a 1 final 7, and we actually don't have any fractions anymore, which is sort of a minor miracle, really. So we're going to take out a 7, so this is going to be x plus 1, and then this is going to be 14. So now we are ready to draw the sine chart. Finally, again, these two really bad algebra steps were necessary because we need to factor as much as possible, but we have achieved our goal. So let's go for it. Let's try to count first how many zeros we have. So remember that the multiplicity, meaning the exponent of each factor, counts as much as possible. So in this case, we have 1, 2, 3, 4, 5, 6. Again, the 14 doesn't matter because it has no x's, so it's 1, 2, 3, 4, 5, 6. And this thing is all positive. So the end behavior, if you watch your sine chart video, the end behavior of this sine chart is going to be regular parabola, something that starts at positive and something that ends positive. So let's draw the 3 zeros. So it looks like it's going to be, if we place them in order, this is -3, this one is -1, and then this one is 1/2. 2x minus 1 equals 0, 2x equals 1, x equals 1/2. Again, because we have an even thing, 1, 2, 3, 4, 5, 6, this is going to be an even parabola. It's going to start on the top, end on the top. Now remember, for zero behavior, what you do is you look at the specific zero that you're dealing with, the factor, and you look at the exponent. If it's odd, it'll just go straight through, it'll cross through the x-axis, and if it's even, it'll bounce. So in this case, as we approach -3, let me try and draw a better picture. As we approach -3, we have the cube, so that's going to go through. So I'm going to go through here. As we approach -1, this is technically to the 1. So what we're going to do is we're going to still go through because 1 is odd. Not my best picture, but let's just finish it off. Notice as we come to the 1/2, because this is even, the power is 2, we're going to bounce. So we're going to bounce here. Not my best picture. But again, the actual curve itself doesn't really matter. All it matters is where things are positive and negative. So let's add that to the sine chart. Remember, this is the sine chart of f prime, not the graph of f, but the sine chart of f prime tells us about the graph of f. So in this case, it's going to be positive, negative, positive, positive. How lovely. Let's get going with the answer. So again, just really just memorize these rules. F is increasing when f prime is positive. So f is increasing, we'll just write increasing. Don't be lazy like me, try to not abbreviate, but running out of room here. Let's just mention all the intervals where this is positive. F prime itself, so it's -infinity to -3. We'll use commas, -1 to 1/2. We'll break it up at 1/2 even if both sides are positive. So -1/2 to 1/2. -1 to 1/2. Can't read the board here. And then finally, 1/2 to infinity. Again, these are the 3 intervals. Don't focus on the curve, just focus on where things are positive or negative. The curve itself just tells you where it's positive or negative. Finally, this little interval right here, we're not going to forget about this guy. This is where f is decreasing because that's where f prime is negative. So f is decreasing. We'll write d is c, when f prime is negative, and this is on the interval, which use the word on, -3 to -1. So again, that's how it goes. This is really maybe the hardest it gets. Again, what you need to do is just factor as much as possible when you draw those sine charts. Take the derivative with product rule and chain rule. Factor as much as possible, no matter how many algebra steps you need. And then hopefully you know how to draw sine charts. If you don't, watch our previous video. You just count the number of zeros to get end behavior, and then you approach each zero, the zero behavior, by looking at the exponent of that factor that relates to that zero. So this is all it is, and then just finally, this is the actual process. F is increasing when f prime is positive, f is decreasing when f prime is negative. So I'm gonna keep going, I'm gonna keep going forever. So I'm gonna do 2 more examples. One example with a fraction, one example with trig, because those are oftentimes people's hardest questions. So let's erase this. We can do this, friends, we can do this. After we're done, we can enjoy a nice Saturday brunch. It'll be very lovely, and we'll also have the knowledge of how to do increasing, decreasing functions, which is always really fun, always comes in handy. Let's get going. So let's do another one. So again, it's going to be f is increasing. We know that this is the question, so I'm going to re-erase it. And my next function is going to be f of x equals x plus Let me get a perfect square to make this pretty nice. Let's choose 64 over x. So this is going to be my next question. Let's get going. So again, first step, let's take the derivative. So we're going to take the derivative here. If you don't know how to take this derivative right here, again, please don't do quotient rule when there's either just the number in the numerator or just the number in the denominator. Try to use power rule because power rule is just so nice. It's our best friend. So in this case, I'm going to rewrite this function as 64x to the minus 1 so that I can easily employ the power rule, remembering that negative exponents mean you change things to the denominator. So this is what this is equal to. Let's take the derivative. The derivative of x is 1. Now we're going to do the power rule. So we take the negative 1, drop it to the front. So it's going to be minus 64 x to the minus 2. And this is what we're going for. So now we draw the sign chart, but you can tell that this sign chart, I'm not ready for the sign chart yet. I'm not confident enough because I don't know what this looks like because we haven't done the big step, which is factor as much as possible. So what I tell my students for derivatives and for integrals, we want to change things to powers because it's easier to take derivatives and integrals. But once we're done with that, we should probably change them back to algebraically manipulate them. So in this case, we did change this to a negative exponent. We did the power rule. So what I'm going to do is change it back to a fraction in order for us to simplify as much as possible, factor as much as possible, because that's always our goal here. So in this case, it's going to be 1 minus 64 over x squared. Still not factored as much as possible. So what I need to do is I need to try to combine these little guys, combine these fractions into one fraction so that potentially that's how things are factored as much as possible in a fraction. Factor the top as much as possible, factor the bottom as much as possible, but you need to have a single fraction. So in this case, I'm going to combine these with common denominator. Keep in mind that the common denominator is going to be x squared over x squared. So it's x squared over x squared minus 64 over x squared. So now, again, it's just a little bit of fraction work. I know fractions are the worst, but I think we'll be fine. We're combining these guys. That's what the common denominator allowed us to do. And then finally, we are going to factor the top here, just the difference of squares. So it's going to be x minus 8 times x plus 8. So just like with the previous example, the derivative itself is not too bad, especially if you write it with the power rule. The algebra was a lot worse, but we got there in the end. Now we are factored as much as possible, in my opinion, because on the top it's x plus or minus something, x plus or minus something, x plus or minus something, and so on the bottom where it's x plus or minus 0 really. So in our previous video, we said that sometimes people are intimidated by drawing sign charts of fractions, but don't be too intimidated, because really what you do, because we're not drawing the graph, we're drawing the sign chart, all we need to do is see where things are positive or negative, so you can basically just ignore the fraction and just draw every single 0 you see, count every single 0 you see, and then approach 0 behavior like we normally do. So in this case, what we're going to get is we are going to plot every 0 we see. So on the top we get 8 and negative 8, and then on the bottom we get 0. So in this case, it's going to be negative 8, 0, and 8. And then we're going to count our zeros just like normal, where exponents heavily affect it. It looks like we have 1 0 on the top, 2 zeros on the top, and then 2 zeros on the bottom because it's x squared. So we have 4 zeros in total. Everything is positive. So an even polynomial function, an even positive polynomial function, that looks like a parabola. How nice. So just like the previous example, it's going to start over here and right here for f prime. And then it looks like as we approach negative 8, that corresponds to this 0 right here. So it's going to go through because it's technically to the 1. Then for this 0, it's also to the 1. And then for x is equal to 0, it looks like it's going to bounce because that's an even power. Remember, it depends on the exponent of the factor. If it's odd, it goes through the axis. If it's even, it bounces. So in this case, we're going to go through at negative 8 because again, it's to the 1. We look, as we approach x equals 0, we look at the factor corresponding to that. That's x squared. It's even, so we have to bounce this guy. Bouncy, bouncy. And then finally, as we go through 8, this is technically to the 1, so we're just going to shoot through that x-axis. It's going to look like this. Again, this is definitely not the graph of f prime, but this is just the sign chart. So this is going to be positive, negative, negative, positive. And that's all it is. This sign chart, because we drew the little squiggly guy, this will tell us how to determine where's f increasing, where's f decreasing because of the rule. So let's do this guy for this one. So f is increasing. I like to write the rule f prime as positive. Looks like it's going to be on the two ends when negative infinity to negative 8 to infinity. So let's write that. Negative infinity to negative 8 to infinity. Hopefully you like my nice little separator squiggly guy. Let's change that to a comma to make things a little bit nicer. And then finally, let's do f is decreasing. The rule is, of course, f is decreasing when f prime is negative. So f is decreasing. This is the word decreasing, or DEC, when f prime is negative, and that's going to be on these two intervals right here, because the sign chart is literally negative. The sign chart of f prime, of course. Negative 8 to 0, 0 to 8. And 0 to 8. We'll write the words and this time to be crazy. We'll stick in the word on. But again, hopefully you can see that even as a fraction, it's not too bad. Identify the function, take the derivative. In this case, we use the power rule because the power rule was a lot easier to use than the quotient rule, and we were able to do that. Then, after we did the power rule, we changed it back to a fraction, and we did a little bit of algebra so that we could finally factor as much as possible, so that we could draw the sign chart. We had an even guy, 1, 2, 3, 4, and it crossed through at these two because they're to the 1, and it bounced. Then, once we approach f prime, we just did the same process as normal. Positive intervals, meaning f prime is positive, means that f is increasing. Negative intervals, f prime is negative, means that f is decreasing. So it was from negative 8 to 0 and 0 to 8. So just one more question, and then we can have our brunch. Let's do trig. So remember that when we have trig, we don't go with our sign chart rules of even, odd, positive, or negative because you're doing trig. You just have to know the basic graphs of trig. So let me erase this. And of course, trig functions oscillate forever, back and forth, always crossing 0. So usually these trig questions are restricted on an interval. So let's do a pretty simple one because again, I want to go enjoy my brunch. Not that I don't mind hanging out with you guys. F of x, let's take f of x being 3 cosine x plus 2. And then what we're going to do is we are going to determine where this function is increasing or decreasing only on the interval from negative pi to pi. So just a nice little period here of this function. Don't really care about outside this function. So when we draw the sign chart, I'm going to stick negative pi and pi. That's going to be our fenced in. We're not going to look at anything from beyond those 2 points. But even if it's trig, the first step is still the same. Take the derivative. So here the derivative is f prime of x. So not hard derivative. We have a 3 here, so we're just going to write the 3 down because that's how derivatives work. And then how do you take the derivative of cosine x? That's memorized as minus sine x. So it looks like I just need to draw this little graph right here. So again, we're fixing this to be negative pi and pi because we don't care about anything beyond this because we're only doing this on this one specific example. And hopefully you know what sine looks like. It starts at the origin, and then keep in mind that this is a negative sine graph. So usually sine goes like this, but now it's going to go like this, right here. This is a graph of f prime. Again, be careful that this is a graph of f prime. So you might be imagining, well, it's increasing from here to here, but we don't care about what this graph actually looks like. It helps us draw the sign chart, positive or negative. Focus on this positive or negative. F prime being positive tells me that f is increasing. So f is increasing when f prime is positive, and that's from negative pi to 0. Let's draw this. Don't focus on where this is actually increasing or decreasing because that's where f prime is increasing or decreasing. Focus on where f prime is positive or negative. So if you were to draw this graph, or if you were to type it in a calculator, you would see that from negative pi to 0, the function would be going up, and from 0 to pi, the function would be going down. So f is decreasing. I can't write the word decreasing. From f prime, the rule is f prime is negative. One last time, because it's negative here, not focusing on the graph, focusing that f prime is negative means f is decreasing. So this is negative 0 to pi. And that's that. So this has been a long video, but I have definitely enjoyed my time spending time with you guys. I don't know if that was grammatically correct, but whatever. Hopefully you see that we're just doing the same thing over and over and over again. F is increasing or decreasing. First step is take the derivative, f prime. Then you want to factor as much as possible f prime, no matter if it's a fraction, no matter if it has e's, whatever, so that you can draw the sign chart as accurately as possible. The sign chart tells you where f prime is positive or negative, and that's great because the rule is f is increasing when f prime is positive, f is decreasing when f prime is negative. You might still need more practice with this, and this is okay because this is a very important concept on AP calculus exams and college calculus exams. So just like normal, we do have a Girls Teach Calculus video in the description below. I hopefully will post this, where one of my former students thinks she goes through more and more of these questions. She does questions involving just basic polynomials. She does questions with trig, like this one, fractions, e to the x's. So be on the lookout for that. Check that out if you want more practice. In the next few videos, we're going to be continuing this sort of exploration of exploring how to find the graphs of f without actually having to draw them using properties of the derivative and the second derivative. So in our next video, we'll be talking about concavity. You'll see that it's very similar, except we do it with the second derivative instead of the first derivative. And then after that, we'll talk about relative extrema. So we'll be revisiting these f prime sign charts. So hopefully I will see you in those videos. Go enjoy your Saturday brunch, and I hope to see you next time. Thanks again for watching.